For each of the following functions, determine whether it is 1 to 1 or not. The first one is f of x is negative 2x plus 1. Well, that is a straight line. So if you do a quick sketch of that, it would look something like this. And any horizontal line drawn on there will only cut once. It's the same for any straight line. So this one is 1 to 1. The next one is g of x is negative x cubed plus 1. So you should have a good idea of what that looks like just from what you did last year in year 11 in methods. So got x and y, and it's going to look something like this. It would have a horizontal point of inflection just here, but the point is any horizontal line on there is going to cut once only. So that one also is 1, let's write that a bit better, 1 to 1. Okay, now we've got h of x is negative x take x cubed. Okay, this one's a bit more difficult. One thing we could do here is factorize out the negative x, and then we'd have in the bracket 1 plus x squared, and that bit has no real roots, so the only root is x is 0. If you found two roots, then immediately what you're going to have is a situation where you have a root there and a root there, and a horizontal line is going to go through those two. So, but that doesn't really help us. We don't know if it's going to do this type of thing somewhere else. One way we can tell with this is to differentiate. We're going to look at this again shortly. And if we do that, that's negative 1 take 3x squared, which is negative 1 plus 3x squared. Now, if you look at what's in the bracket, that has to be positive. So overall, this has to be negative. So we're looking at something where the gradient is always negative. I'm not saying it's going to look like that. But if the gradient is always negative, it can't turn back up. And therefore, any horizontal line is going to cut once only. So this one also is 1 to 1.